Let's talk about a few useful numeric functions. So SAS offers a full range of numeric functions. We've already met the square root function. You can guess what that does. I've already talked to you about logarithms. EXP computes the exponent, so it takes e to the x. You probably will never have the occasion to use sines, cosines, tangents, arctangents, all that sort of stuff. But if you wanted to, they are available to you in SAS. A few other numeric functions that I find pretty useful. One is int. So int strips off the decimal point. So if you say, int of 3.14, it's going to return 3. So it just throws away all the decimal portion and retains only the integer portion of x. ABS gives you the absolute value. Round rounds a number to the nearest integer. If you wanted to round it to the nearest, say, tenth, you'd specify an additional argument, which would be 0.1. If you wanted hundredths, you'd say 0.01, and so forth. So let's look at a little example. I've read in 6 numbers. Let's take the int, the absolute value, and we'll round it. And then we'll look at the results. So here are the results. So the int of 1.3 is 1, so just threw out the 0.3. Likewise, the int of minus 2.3 is just minus 2. It threw away the the decimal part. The absolute value is just what you would expect, and then rounding does what you would expect. So 1.5 rounds up to 2, minus 2.5 rounds down to minus 3. So that's what the round function does. One more function that I find pretty useful is the mod function. So I know I've told you about mod in SPSS when we back in fall. What mod does is it just returns the remainder after you've done a division. So let's make this real clear with an example. So I'm going to read in the values 0 through 10. I'm going to talk more about the at option next time when we talk about advanced reading data in, and so I'll talk more about it then. But what at says is it says hold the line. So do not go to the next line. So input x, it's going to read in 1, and then this means hold the line. So then it's going to read in the next number, and so forth. And so if we print this, you'll see that it's read in 0 through 10. Now, I'm going to compute x mod 4. So we write that as mod x comma 4. What this says is divide x by 4 and return the remainder. So let's go see what we get. If you take 0 divided by 4, you get a remainder of 0. If you take 1 divided by 4, you get a remainder of 1. All right, 4 divided by 4 is 1, and the remainder is 0 because it divides evenly. Whereas if I take 5 divided by 4, well, 4 goes into 5 one time with a remainder of 1. 6 divided by 4 is 1 with a remainder of 2. Okay, so what you'll see is that this just goes, well, 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3, and so forth. If you want to know the integer division part of this, so if you'd use the int function. So what you'll see is that 4 goes into 0, 1, 2, and 3 less than once. So the div part is 0. And 4 goes into 4, 5, 6, or 7 one time with various remainders. So the div part is all 1 here. X goes into 8, 9, 10, and 11. Well, 2 times with some remainders sometimes. And so the div part is always 2. So that is integer division and the remainders that you get from integer division using the mod function. So those are the most useful numeric functions. Let's move on to strings. So there are many string functions in SAS. These string functions are pretty universally available in other languages, perhaps with other names. So if you know how to do it in SAS, if you understand what these functions are in SAS, you can jump over to Python, Perl, C, Java, whatever you like, and you're going to find pretty similar functions in any of these languages. Increasingly, we have to deal with a lot of text data. So we get comments, we get URLs, and that's a lot of string data that we're going to have to be processing. So these string functions are probably the most important part of today's lecture, and we really haven't talked about them yet. So remember, a string is just any sequence of alphanumeric characters. Here are some basic functions. So the first one that I'll talk about is length. So length is just going to tell us the number of characters in a string. So I have a little example. We'll input S, and I've made the string up to 20 characters, but not all these lines are 20 characters long. And I've just typed a sentence over a couple lines here. This is, for those of you who don't recognize this, this is the classic typing exercise. If you took a typing class, you probably had to type this sentence many, many times. So if we look at that first line, now is the time. I've computed the length of this and stored it in the lens variable. So that's 15 characters long. Now we could go off and count it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that's what the 15 tells us. For all good men, you'll see that's a character longer, so it's 16. To come to the aid, that's 18 characters long. Of their country is 17. So that's what length does. It just tells us how many characters some string is long. Another really useful function is the substring function. And substring takes some string S, and it's going to return another string. So it's going to say return beginning in position start num characters. So I've pulled two substrings just to give you an example. Substring S53 means take string S, go to the 5th character, and give me 3 characters. So let's go take a look at that first line. What is the 5th character? So the N is 1, 2, 3, 4. The 5th character is that I. And now I want to return 3 characters. So what are the 3 characters? Well, it will be IS space. And so that's sure enough what that is. The next line, the 3 characters beginning at position 5 equals all. What about the next line? Well, it's going to be OME and then HEI for the next line. If you don't specify a third argument, so for example, if I say substring S comma 10, what that means is give me a substring beginning in position 10 to the end of the string. So if you look at that first line, the E is position 10, and it's going to give me all the way to the end of the line. So E time, ud men is the next line, and so forth. So that's what substring does. Upcase and lowercase convert some string. So let's look at upcase. I didn't give you lowercase, but you can imagine what that does. Upcase is going to convert all the characters in string S to uppercase. So let's go look at the result. This is especially useful because sometimes people are inconsistent. You're looking for a word. You know, I want to find the word angry. If I'm searching for sentiment that it would indicate if I'm mad, if somebody wrote the word angry, well, sometimes they might write it in all caps, sometimes they might capitalize it, sometimes they put it all lowercase. And if you're searching for that, you want to first make it uppercase so you don't have to search for all possible combinations of upper lowercase angry. So that's very useful. So those are some basic functions. Let's move on. Sometimes we want to paste strings together. So In some languages, it's called paste. That's what R calls it, by the way. In SAS, it's called concatenation. By the way, the cat command in Unix is short for concatenation because you're concatenating files. So how do you do string concatenation or pasting strings together? Well, there's an operator, which is one way to do this, and it's the way that I tend to do it by default. So if you use a double vertical bond, what that means is paste string B to string A. So I've put together a little example. Let's read in two strings, both with length 8. So we have two names. The first name and the last name. A happens to be the first name, B is the last name. So you got Bill Gates, Steve Jobs, and Barack Obama are my three names. Now I'm going to make a brand new variable. Let's call it cat1. Cat1 is A, paste or concatenate B. Let's go take a look at what we get. And here's what you get. You get something you don't want. So you get Bill space 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 Gates, Steve space 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 Jobs, and Barack space space Obama. The reason for this is these strings are stored with length 8, and what SAS does is it pads the end of the string with spaces. So Bill only takes up 4 characters even though it's an 8-character string. So that's why you're getting those extra 4 characters right there. So how do we get rid of those 4 characters? That brings us to another function which is called trim. So what trim does is it removes the trailing blanks from A. What you could think of is what SAS is doing is it's saying you could translate trim into substring A, comma 1, so start at the first position, comma length A. So it's going to return to you the number of characters in string A. So trim just does that substring A, comma 1, comma length A for you. So let's take a look at cat2 now. What cat2 is going to do is it's going to trim both string A and string B, and then it's going to use the concatenate operator, double vertical bond symbol, to paste them together. So what do we get if we do that? Well, now we get Bill Gates without anything in the middle, Steve Jobs without anything in the middle, Barack Obama without anything in the middle. But that's not what we want either. Presumably we would like to have Bill space Gates. So how do we do that? Well, cat3 is one way to do it. So what I do in cat3 is first let's trim A, concatenate that with the string constant space, concatenate that with the trimmed version of B. And this gives us more what we want. So Bill Gates, Steve Jobs, Barack Obama with the first and last name separated by a space. Well, doing this sort of stuff is really common. You often want to paste strings together and separate them by something. So SAS offers the catx function. So what does catx do? Well, catx will paste the sep string between all the strings that you list thereafter. Now, I've only listed 2 strings, but we could list as many strings as we like. So, for example, if I say cat x space AB, this will give us exactly what we want. So perhaps this is a bit easier than using the concatenate operator, pardon me.